Okay, just tell me if I'm audible or not. Okay, I don't know if anyone has joined or not. Okay, okay, so just tell me if I'm audible or not. If I'm audible, then I'll start with the video. Okay, let me keep it over here. It's better. I'll just do one thing. I'll just quickly check from my side if I'm audible. If I'm audible. I'll just start with it. Just a minute. Okay. Okay, so I'm audible, right? I'm perfectly audible. So let's start with today's contest. I mean, today's solutions. Okay. Oh, I think I forgot to turn on the chats. Just a minute. I'll just quickly turn on the chats. So, okay. Just remove this and open this. Excalibur. I think it works perfectly. Yeah, it works. Okay, so let's start with the first problem of today's Leetcode challenge. So that was adjacent increasing subarrays detection part 1. So what the problem states is basically you're given an array nums of n integers and an integer key. Okay, you have to determine whether there exist two adjacent subarrays. So what do you mean by adjacent? It means that it is one by one after each other. Okay, so if there are two adjacent subarrays and that is not where we are going to stop, such that both subarrays are strictly increasing. Specifically check if there are two subarrays starting at indices A and B, such that both of them are increasing and both of them are adjacent. Okay, so what are the conditions we are going to have? One is they should be adjacent, that means just one after the other, and this should be strictly increasing and this should be strictly increasing. Okay, so we have to find out whether it is possible to have such a thing or not. Okay, very simple, right? So anyone have got any idea, like anyone did this question? Just write in the live chat. I'll just start a poll. Okay, start a poll. A done. Because I think A was easy. Like most of the people must have done it, but the A was not as easy as it used to, like in other contests, which is also something that I feel like. A done, right? Okay. So basically, but still, I'll just explain you what A is. So what you have to do is you have to simply like set this part. Okay, this part. I have two questions. Let's do one thing. Let's just explain the first one quickly, and then I'll just go to the second question and get it. So now basically, now think it this way that if A is like if we're going to fix the position of this part, okay, and for that specific part we are going to check like whether the next k elements are strictly increasing and the next to next k elements are strictly increasing or not. If it's yes, then we can write say that it's a yes. Okay, so quickly I'll just go through the code. I'm going to n minus 2 into k because we are going to check for the next 2k elements, right? So we don't need to traverse through the whole thing. C was tough or not? According to me, it was. C was what? Uh, yeah, C was tough. C was tough, right? C was like yeah, it was tough, but not that much. Okay, so what we do is then we are going to check from I plus 1 to I plus k, and then from I plus k plus 1 to 2 into k. And if at any position we find that it is not strictly increasing, we are just going to make it false. And then if it is true for some case, we are going to return true. Otherwise, we return false. Okay. So I think that A is clear for everyone, right? A is clear for everyone. So now I'll just re-poll this. Just end this poll. Start another poll regarding the B. B done. Eh. So how many of you did B? B done. Okay, that's nice. What was B though? I forgot. Oh, it is like a better version of the A only. So just let's go through the question first. Given an array nums of n integers, your task is to find the maximum value of k for which there exists two. I did B with binary search. You did B with binary search. What did I do it with? Mm, I don't think you needed binary search. This. I'll just explain you B. Don't need to worry because like if we can do it in big O n, why would I even go for? Or like, did you do it with just binary search? You did it in big O log n or big O n log n? Soumya? Okay, then just watch my solution, okay? Because that will be better for you. Now see what the question tells us. It is similar to the first question. Just the fact over here is we have to find what is the maximum value that k can hold. Okay, let's go back to Excalibur and now focus on this. Okay, hi. Now focus on this. Okay, so just a minute. So what was it though? It was we were going for. Okay, now it's similar. So let's say we are having two arrays. I mean two values of k, right? So this is also k length and this is also k length, and it's satisfied for both of them. Now think about it this way: that what is the maximum value of k that we can get? So in spite of going what we were using usually, first of all, what you need is basically you have to find out what is the like till that position you can find out what is the maximum maximum length sub array ending at that position that is strictly increasing, right? We can do that, right? So let's say if you're having 1 2 3 1 2 1 2, so what will be the values of this? Like for your better understanding, I'm just going with a basic simple example. What should be the values for this? For this it will be 1 because there is only length of 1. For this it will be 2, and for this it will be 3 because all these three are strictly increasing, right? But again for this it will be 1 because nothing before it is strictly increasing. Now again it will be 2, then again it will be 1, and again 2, right? So is this clear? I think I should have taken a different example. Let me just take a different example. 3 7 9 4 5 1 9. Okay, so this is like because all the numbers that I took and the values of that thing that you got were same. So I'm just taking a different example. Now see till 3, this is the subarray that is the largest increasing subarray. And for this it is 3 7. And for this it is 3 7 9. But when we are going to 4, if we want to end something at 4, the element just before it is not strictly decrease. I mean, not lesser than that. So 4 solely, only 4 alone, it is going to have that value. Okay, so that is 1 again. Then 4 5 is 2, and then 1 again, same case. So it's 1, it's 2. So is this part clear with you guys? Just quickly tell me if this part is clear with you guys or not. Okay. Yeah, clear. Now comes the next part of this question. Okay. Anyways, guys, just be a little bit responsive, and I think if you are new to this channel, just subscribe my channel and like the video, nothing else. Okay, so now focus on this. Okay, now since we have got this, okay, we are done with this, so this is clear, right? Now comes the main part. Let's say we are at a specific position. Okay, we are at a specific position, and we know the values of the thing that we did. That was, I think I named it something. I forgot the name that I gave it. It was maximum increasing subarray. Okay, so the maximum increasing subarray that ending at I, it can be done like this if nums of I greater than nums of I minus 1, that is, it is strictly increasing till now. So we can say whatever the length it was earlier, it is going to be plus 1. And if it's not increasing, so it means that the subarray starts from that place only. So it is by default 1. Okay, it is by default 1, and otherwise it increases by 1. Clear? Now comes the main part. Okay, now let's say you have got a specific position. Now the length of the maximum subarray was, let's say it was, just a minute, I'll just plug my charger, okay, because my device is having a little bit of lag. Just a minute, okay. So yeah, where was I though? I was explaining you this, right? Now see, if you're having something at the, like, let's say you have got this position, and the length of x, for a length of x, it is increasing till that position. So if we are going to take the middle point, let's say the array is a lengthier than this, okay, and this till this is a maximum increasing, this is a length of the increasing subarray. Okay, now if we put a division the middle, now we can say that this is also strictly increasing and this is also strictly increasing, right? Is this clear? Because the length of x is strictly increasing, so if we divide it in two parts, both of them are strictly increasing. Is this part clear or not? Yeah, so this is the best possible answer, right? It may seem that this is the best possible answer, because if we are going to, let's say, this thing holds for a lot of cases. Okay, let's say for if for x it is increasing, so for y that is lesser than x, it is also increasing, and then we can divide y into two parts. But since we have focusing more on the maximum part, so basically y by 2 is not a better answer than x by 2. Okay, so that is the reason we are taking x. That is also, I guess, clear. Now comes the main part. Okay, what if what if this whole thing is the value of k? So if this whole thing is the value of k, so there should be also a value of k which is strictly increasing, right? So in that case, what is the thing that you're going to check for? It's the most important thing, right? Now let's say we know the value, this k and k is not equal initially because we were just assuming that they were equal, but it was not equal. Okay. So let's say this was x and this was y. Okay. Now I have to make them equal to get a better answer, right? So what I can do is either I can check, I can make this x and this x so it becomes equal, or what I can do is I can make this y and this y so that it becomes equal. What is a better option to do? To make the smallest, whichever is smallest, to make it equal, right? Are you getting this? Are you getting this? Just tell me. So this is a little bit complex of a concept. Example. Okay, I'll just take an example. So let's just rub these things out. Okay, just rub these things out. And what I'll do is I'll go to this question itself. Oh, this is done. Right? I'll just go to this question itself, and I'll take big one, a big example. Okay, this one. I don't know whether I can paste it or not. Yeah, I can paste it, right? Oops. Just a minute. Just a minute. This is okay, right? The visibility is okay, right? Okay. Now see one thing. Now, if you're taking this example, so I'm going to simultaneously, oops. I'm going to simultaneously take an array for this also. Just array for this also, okay? Now, what are the values? 2, 5, 7, or rather, let me do one thing. I'll take an array for this just below this. Okay, now just think about what is the increasing thing. Okay, just increasing, maximum increasing array looks like. Okay, just be interactive. So initially it is 1, then for 5 it is 2, for 7 it is 3, for 7 it is 3. Okay, and then for 8 it is 4, for 9 it is 5, for 2 again it is 1, for 3 it is 2, for 4 it is 3, and then again for 3 and 1 it is going to be 1 and 1, right? So this is what it looks like. Any problem till now? Just tell me if any problem till now. Yeah, I thought of this but didn't know how to use this hashed array. This is not hashed array. Like, okay, like you may name it something you feel like. Okay, so this is clear, right? This part is clear. Now think about this. If we are at 5, this position, okay? When we are talking about 5, we are talking about this position. So if we are at 5, get this position. And then what we want to do is, the first we are going to think of the by 2 thing, okay? So let's say we have a array of size 5 which is satisfying. So what I can do is I can divide 5 by 2. What it becomes 2, which means I'm going to consider the value of k as this and the next k as this. Both of them are strictly increasing, right? Is it clear? Both of them are strictly increasing. Is this part clear? Yeah. Now there is also another possibility that we are going to take the whole thing and then we are going to take what is before it. So since there is nothing before it, and we have to equalize them, okay, right? We have to equalize them. I told you. Since there is nothing before it, so this is 0 and this is 5. So if we want to equalize it, it becomes 0 and 0, right? We can't make the previous thing 5. We can't make this 5, right? We can't increase something. We can't decrease something. That is like remove some of the elements. So what do I mean by decreasing something? It becomes like, let's say this is a strictly increasing subarray. Okay. So what we can do is we can remove some of the elements from it and decrease its length, but we can't increase it, right? We can't add some of the elements because in subarray we are just decreasing some of the elements, not adding. Clear? I hope this is clear actually. Okay, so this was the example. Sorry. So basically, if we are having a subarray. Sorry, if we are having a subarray, we can remove some of its elements and decrease its length, but we can't increase its length because the subarray is basically nothing but removing some of the elements from it, from the array, right? Now let's come back to this. Sorry. Uh, so for 5 it is not satisfying according to our like theory, right? Now we come to 3. Okay, so what is 3 by 2? It is 1, which means again this is a possible thing and this is a possible thing. So what is the value of k now? It is 1. But earlier we got a value of k as 2. So that is a better solution. So we are going to ignore this. And then the second condition comes. Okay, what is the second condition? Check for this and check for what was before this. So what was before this? It was 5. And what is now? It is 3. So which is minimum among this 3 and 5? It is 3 is minimum. So we can reduce this 5 to 3 by removing the first two elements. So if we remove the first two elements, so now this is 3 and this is 3, right? So both of them are 3. So it works. So both of them are 3, right? So it works, right? So is it clear? And 3 is the answer basically, if I'm not wrong. 3 is the answer, okay. So is it clear how we are getting it? Quickly tell me if it's clear or not. Got it? So now let's go to the code once quickly. This part I explained you, and then I'm checking for maximum increasing by 2 because that may be a solution, or maximum increasing of I, comma, maximum increasing of I minus maximum increasing of I. That is the two parts. Okay, so among the two parts, whichever is minimum, we can consider that also. And remember one thing, this I minus maximum increment of I, if it should be greater than equal to 0, what does it mean? That is the first condition, okay? That is this condition where there was a 0. But since in real life we don't have a 0 in front of it, right? So it will be giving us array index out of bounds. So that is the reason, like, you have to do it, okay? So if you do it, it is accepted, you can see it, okay? So I hope this is clear with you guys. So can I move on to C? Okay, C not done. Okay. How many people didn't do C? So how many didn't do it? Okay. C, even I took a lot of time to do C though. It's okay. Which one do you need me to explain in detail? I'm watching you carefully. Which one, the B or the C? C. Yeah, I'll explain in detail. So first, let's go through the question. Okay, you're given an integer array nums. A good subsequence is defined as a subsequence of nums where the absolute difference between any two consecutive elements is exactly one. Okay, a subsequence is an array that can be derived from another array by deleting some or no. We know what a subsequence is, right? Without changing the order of the remaining elements. Return the sum of all possible good subsequences. And the answer should be modulus of 10 to the power 9 plus 7. We know that. Note that a subsequence of size 1 is considered good by definition. Okay. So let's take this example 1, 2, 1. Okay. What does the question mean? First, you have to understand what the question means. Okay. So, let's say we are having 1, 2, 1. Right. So, what are the good subsequences over here? And we know that anything of size 1 is a good subsequence. Okay. So, there are three subsequences that we have got already. I'll just do one thing. I'll just move the chat a little bit over here. I was able to think in kind of backtracking with AR back minus current, but what it was backtracking. It was a DP question. Just a minute, I'll just check through my solution also. Yeah, it was a kind of DP question, a DP frequency thing, that kind of question. Okay, how you came up with the solution? How I came up with the solution? I think you mean that how I came up with the solution. I don't know. Okay, now look at this. Okay, so three are already there. Now, apart from this three, the first element, if we are considering that we are at every position, we are going to consider that that element is there. Okay. So, if we are going to consider just the first element, okay, that is, I'm going to delete these two elements. Okay. So, I'm going to consider just the first element. So, in that case, there is only one possibility, that is one. Okay. So now I'm just going to divide it. Okay. Divide the whole problem into parts, the various parts. That is considering just the first one. Okay, just the first one. Remove these. Okay, for now. So what is it? So we can have one, right? Now what we are going to do is, now we can consider the next two and remove this. Okay, now for the next two, so let's say if I'm ending at 2, okay, if I'm ending at 2, what is the possible value for that? So 2 can be there individually, or it can be there with the 1, right? So there is also another possibility. So what was the first possibility? It was 1. What is this possibility? It's 2 alone. And what is this possibility? It is 1 comma 2. Right? Now comes the most important part that we are going to consider all of them together. Okay? I'm doing it in red so that you guys understand it better. So now we have to consider all of them. Now this 1. Okay, now we have to find out what 1 can be paired with. This one. What when I'm talking about 1, I'm talking about this one. Okay? So what this one can be paired with. Now see, if you want to pair this one up, so you can pair this one with only 2, right? Because that is the only possible thing that you can have. Now for the specific 2, you have to find out how many were there for the 2. Okay. Now see, that is the most interesting thing. So what is this one can have? It can have it alone. It can have itself alone. Or it can take help from all the 2's. That is the other ones. That is these and this. This one took help from this one, right? Because this one was over here. Now this one is going to have itself alone once, and I'll just do one thing. I'll move my screen a little bit over here. Now it can have alone. The one can be alone over there also, And for this case, along with the 1, we are going to consider this 2. So that is 2 comma 1. And then we are going to consider this also. That is 1 comma 2 comma 1. So how many total possibilities are there? 1 for the first one, 2 for the second, like the 2, and 3 for the last one, right? So what do this sum up to? So this sums to 1. This sums to 2 plus 2 plus 1, that is 5. And this sums to 2 plus 2, 4, 5, 6, 7, 8. 8. Now if we add them up, it becomes 14. And if you check the question, check the answer, it is also 14. So is this explanation clear for you guys? Tell me. Yeah, it is clear, right? The explanation is clear, I guess. Now since the explanation is clear, I'll just move this thing along. Okay, now it is visible like properly. Now we are going to come back to our main solution. Okay, what we are going to do now, see, since we were deriving something from somewhere, right? The derivation was there earlier. I'll just move on to this. Okay, just look at this. Okay, since there were derivations, right? There were some derivations. So that means that whatever the sum was earlier for those values, they are going to be in the next values, right? What do I mean by this? Let's say for this one, okay, the sum was 1, right? For this one, the sum was 1. Now for this 2, the sum should be 2, right? It should be 2 because we are going to consider one element also. But along with this 2, there is also another possibility that you are going to keep this 2 as well as the previous one. So that is 3. Okay, this part. I'll just use a different color. Uh, Blue is okay, I guess. No, blue is also used. I'll just use black only. So this part, right? So I can have 2 as well as 3. Now since we got 2 and 3, now let's come to the last part. Okay, that is this part. So this is having 1. Okay, this is having 1 already. But apart from this 1 also, it is going to have the 2 and 3 of the previous one. And we are going to add 1 to them also. That is 2 plus 1, 3, and 3 plus 1, 4. So is this clear? Is this clear? Because now what happens? This 1, it is 1. This 2 and 3, it adds up to 5. And this 1, 3 and 4, it adds up to 8. Clear? Is this clear? Like how we are going to derive something from the previous stacks. Clear? Okay. Now see. Now comes the code for the derivation. Okay, like how we are going to derive from it. Now for this case, you are seeing that for this one, okay, this one, sorry, for let's say for this one, okay, for this one, what we are going to do is we are just taking 2, right? We are just deriving from 2, but it may also happen that there was 0 earlier, okay, because we know that for it to be a good subsequence, it can be either 2 or 0, because it can be either 1 minus 1 or 1 plus 1. So we are taking the 2 plus 1 thing, but we are not taking 0 because there were no zeros. So it may also have 0, so we have to consider both of them for that. Okay, so what it depends upon, it depends upon what that specific element -1 and the specific element +1, because that are the two positions that is going to satisfy for the good subsequences, right? Now let's go to the code. I'm having a frequency. Why do we need a frequency? Because frequency tells us how many times that number is added. So like, see over here, for 1 it was added 3 times, right? 1, 2, 3. This is what the frequency tells us basically. So there were 3. Why 3? Because two of them he is going to derive. Two of them he is going to derive from something else, but one is his own, right? So that is basically nothing but adding all its derivations. Okay, frequency is nothing but adding up all its derivations. That is frequency of nums of I minus 1 that I was telling you right now. That is, we are going to consider that number -1 and that number +1. Okay, so that is, one is nums of I minus 1 and the other one is nums of I plus 1, and one of it is going to be contributed by itself, because even if we are going to consider just one element, then also it satisfies, right? And then for all the frequency we are going to multiply nums I, because that is the thing that is going to be added to it, right? Blindly we can add it to it, and then what we do is we are going to add the specific sum that it produced for nums of I minus 1, and then we are going to add the specific sum it produces for nums of I plus 1, right? And then we are going to also update the frequency of it. Okay, we are also going to update it. This is not important. This is just, I was just checking. So is this clear? Is the code clear? Because I think this is only what I explained and this is the code what it tells. Is the code clear? Just tell me. Quickly tell me if it's clear or not, okay? If it's not clear, also tell me, like, quickly. If I get no response, I'll just move on to the next problem. Okay, please go through it again. So, if I'm not wrong, you got the idea of this derivation, right? You got the idea of this derivation. Now, from that part, what we can say is, this is the part where we are derivating. Just this is the part that we are derivating, right? Now, see, since we were talking about just derivation, so that derivation doesn't, you know why we were derivating this? Because if it is 1, so the previous element can be either 2 or 0, right? Because what our condition tells us that uh, a good subsequence is different. A good subsequence is defined as a subsequence of nums where the absolute difference between any two consecutive elements is exactly 1. So if we want to make two elements, if there are two elements and one is 1, so this can be either 2, so that the absolute difference between it is 1, or this can be 0, so that the absolute difference between it is also 1. Clear? So that is the reason why we are going to take for nums of I minus 1 also and nums of I plus 1 also. These are the two places that we are going to derive our values from. Okay, the derivation is clear because you just confirmed, I guess, that time that the derivation was clear for you. Now what we do is we are going to simply add that to the sum, because the derivation is something that will always be added. Okay, but apart from the derivation, so apart from the derivation, what happens is uh, the code. Please go through it again. The code. Yeah, I'm going through the code only. So apart from the derivation, what happens is basically you also have that element some number of times, right? Over here, this, what was this? This was, I'll just erase this. Okay. So what was this? This was 2, right? And this was 1 comma 2. So over here you can see that this 2 got derivated in the next one, and 1 comma 2 also got derivated, right? So whatever was there in the previous thing, I mean nums of I minus 1, it is there. So we are going to add it blindly. We are going to add it. Okay, we are going to add it blindly. This thing we added blindly, but after we are added with it, now comes like how many times we are going to add this number, right? So apart from these numbers, sorry, not these, apart from these numbers, okay, what are the numbers that we are adding? We are adding the specific number 1, that is this number only, right? How many times we are adding it? 3 times. How can we say that it's 3? Because this thing happens twice. That is the frequency that the previous element occurred. Okay. So for that we are going to add 1, and also we are going to add one extra one because we know that a subsequence of size 1 is always a good subsequence. So we can just have this 1 independently also. Okay. So this independent one is this one. This independent one is this one, and the dependent ones are this and this. Now is it clear? Now see, you may think that in this case we were just deriving from these two, but over here we are having two. So I think it will be better if I explain you with some other example. I'll explain you with 3, 4, 5. Okay, I'll explain you with 3, 4, 5, and I think that will be clear for you, right? 3, 4, 5, right? We have got 3, 4, 5. Now look at the explanation clearly. So for 3, we are going to have 1 3 only, right? Nothing else. For 4, what we can have is we are going to have this 3 as well as the 4. So how many times 4 will be there? Twice. So that is 3 comma 4 and 4. So 4 will be twice, right? And for this 5, okay, whenever we are coming to this 5, we are going to basically have nothing but the fact 3 comma 4 comma 5, 4 comma 5, and 5 itself. So you can see one thing, that 3 4 5 exactly. So you can see one thing, that this 3 is there, this 4 is there, this 5 is there. So one of it is always there. So what is that part of the code? This is that part of the code, okay? This part. So one of it is always there, okay? Now, let's say we're going to reverse the whole thing. Okay, now we're going to reverse the whole thing. What we're going to do is, we're going to go back a lot of steps, okay? We're going to go to the beginning, and now I'm going to reverse the whole thing. I make it 3 5 4. Now remember one thing, that if it is 3 4 5 and if it is 3 5 4, the answer will always be same, because in subsequences, I mean, because in this case it will be same. Okay, why is it so? Like, not same, but I think this will be a better like understanding for you, the 3 5 4 condition. Now see, for the 3, What is it? It is 3, right? For 5, it is 5. There won't be any 3 form of 5, right? This is the condition where only frequency plus equal to 1 LL is mattering. Okay, this is a condition where only this is going to matter. This is not there. This is not there. Neither this is there. Neither this is there. Neither this is there. Okay. Sorry. But whenever we come to this 4, okay, this 4, that is the part where the most important thing occurs. Okay. So what will be for this 4? Any idea? Any idea what will be for this 4? Yeah, 4 is always there. 4 is always there. Right. But anything else you can think of? 3, 4, exactly. Anything else? 4, 5. Not 4, 5, it's 5, 4. Okay. But anyways, yeah, it works. So there can be 5, 4 also. Now, see the derivation, okay. Just follow the derivation. So this 3, 4, it got derived from here. And this 5, 4, it got derived from here. So it not always mean that the derivation is from just one place. It can happen from more than one place also. Okay, why is it so? Because 4 minus 1 is also 3 and 4 plus 1 is 5. So it is going to derive from two places. So that is the reason we are deriving from two places. That one is nums of I minus 1 and one is nums of I plus 1, right? So this is also we are going to add, and we are going to have a frequency of 1 for this also. So now is it clear? I hope this is clear right now, because I just went through the basics. Just tell me if it's clear or not. Yeah. Okay. So let's move on to the next question. You're given a binary string S representing a number n in its binary form. You're also given an integer k. And integer x is called K-Reducible. If performing the following operation at most k times, reduces it to 1. So what is it? We are going to convert it to the number of set bits in that x, okay, in one operation. So basically for 6, the representation of the binary representation is 110. How many set bits are there? 2. There are 2 ones in it. So now it becomes converted to 2. And what is the binary of 2? It is 1,10. So how many ones are over here? It is 1. Now since it is 1, okay. So we have to reduce it to 1, right? And we are having at most k times that we need to reduce it. So we have to find out, denoting the number of positive integers less than n that are k reducible. That is, it can be reduced in at most k steps. Should I go? I think I should explain this thing, okay, quickly. For 1111, okay, for 1111, just look at it. Ah, 111, okay. And the k value of k is 1, okay. So what is 111? It is basically nothing but 7. So we have to check for 1, 2, 3, 4, 5, 6. 7 is not there, right? We don't check for 7. Now for 1, it is already reduced, right? So 1 is a possible thing. So I'll just make it green, okay? For 2, we just checked out this, right? For 2, so 2 converts to 1 in just one step, right? So this is also a valid thing. 2 is also valid, right? But if we look at 3, okay, so what is the binary of 3? This 1 1. So what does it convert to? It converts to 2. And what is the binary of 2? It is 1 0. What it converts to? It converts to 1. So how many steps did we take? We take 3 steps, right? I mean, sorry, 2 steps, right? But over here the value of k is 1. So we can't take 2 steps. So this is not a possible thing, okay? So we're going to cut this off. 4, you can check it, okay? The binary of 4 is 100. So how many set bits are there? Only 1. So gets converted in one step only. For 5 also it doesn't work, and for 6 also it doesn't work. You guys can check it by yourself. Okay. So what are the values? That is 1, 2, and 4. Right. So there are three values, right? Three values, and the values are 1, 2, and 4. Similarly, you can do for the other ones also. Now let's come into the logic of this whole thing. Okay. So what is red? Red is basically the reduced. Okay. After one step, what it becomes after reducing. So let's say if I'm having a value of n. So after one step, what we do is we are going to check out what are the set bits, the number of set bits, and it gets converted to that, right? Now see, we are having a pre-compute. Why do we have a pre-compute? Because we know that the length of the string is 800. Maximum length can be 800, right? So what is the maximum number of set bits it can have? It can have maximum 800 set bits. So basically we are going to check, like we are going to compute that for every specific value, for if we are having I number of set bits, so how many times do we need to reduce it so that it becomes 1, right? That is what we are going to mainly discuss about. So how can we do it? We are going to reduce it once. Okay, we are going to reduce it once. And so the value decreases, right? After reducing it once, the value decreases. And we have already computed what the value should be. So we are just reducing it by 1 over here, and then we are computing what the value should be, and then we are starting it. So at this moment, what we have that how many times this value should be. If there are x number of set bits in a number, so now we know that how many times we have to perform the operation so that it reduces to 1. We have it in what we have this in. We have it in pre-compute, the vector called pre-compute. Then we are going to find out the count set bits frequency. What is it? I'll explain. Look at this, okay? Look at this right here. Let's say you've got some count set bits. Okay? You're at a specific position. What were we taking as an example? It was 111. That is 7, right? Now see, in 7 we are not going to consider 7. Okay. But apart from 7, we know one thing, that we can have either 2-bit set. Over here there are 3-bit set, right? But we can either have 2 or 1. Or let's say for now, the time being, we are also going to consider 3. Okay, so since there are 3-bit set, so we can either have 1-bit set, the 2-bit set, or 3-bit set, right? So if we are going to have 1-bit set, now a more important concept, that is what the pre-compute for 1, 2, 3 becomes. Okay, so for 1 it is 0 because it is already 1. For 2, if we reduce to ones, it becomes 1. So it is going to be 1 plus 0, that is 1, right? And if we reduce 3, it becomes 2. So that is 3 plus 1. I mean, sorry, not 3 plus 1. That is 1 plus 1, which makes it 2. Okay, clear? Now tell me, how many numbers are there from 1 to 6, or rather from 1 to 7 only? Sorry, we are not going to consider this, okay? We are not going to consider this. For 1 to 6, for which just 1 bit is set. It can be either 1 or 1 0 or 1 0 0. So this is 1, this is 2, and this is 4. Right? Clear? And for 2-bit set, it can be either it can be like a lot of other numbers. Okay, it can be a lot of other numbers. We don't need to focus on it because we know the value of k was 1, right? So since the value of k was 1, so we are going to only consider the 1. And what are the values over here? 1, 2, and 4. So is it clear like how we are getting this 1, 2, and 4? Similarly, if you can go and check for the other ones also. Okay. So once you get the 1, 2, and 4, what you have to do is you have to just go through the frequency array and just add the frequencies and make it mod that and just output the result, and it comes out. Oh, this is not the answer, but yeah, comes out. Okay. So is everything clear? The fourth one is a very logical thing. Like you can search on Google, like how to get how many numbers are having X number of set bits before the value of n. You can get it. I think you will get like that's a mathematical approach. So I'll just explain you how the mathematical approach works also. See, we know this, right? Whenever we are going to have all the numbers one by one, so how do we write all the 4-bit numbers? We write it like this, 0 0 0 0, right? Then we go for 0 0 0 1, then 0 0 1 0, and 0 0 1 1, right? So we go like this, okay? So let me do one thing. Let me just remove these. Okay, so in this place you can see that it is 0 1 0 1 0 1, and in this place you can see it is 0 0 1 1. So basically, for every specific position, we can say one thing for sure, that it becomes like half of what it was earlier, right? The number of zeros is half of what number of ones are. But there is a slight of modification, because we are not only going to consider like perfect, like in the previous case we considered 7, which is having all the bits as set, but it is not the case for all of the test cases. So yeah, that is the place where you will be struggling a little bit, but you can like Google it out. Okay. So I hope I'm good with this. Okay, so I'll just read the problems also, right? I'll just quickly read the problems. So this is easy, medium, hard, and impossible. Okay. The first one was not that easy. I'll keep the first one A over here. And the second one was medium. Third one was over here. And D I will keep in impossible, because the logic, like, because just this is just because of the time constant, okay? Because if you're having a contest for 1.5 hours, it is difficult for you to understand like and come up with the logic for D. So that is the reason I'm keeping it at impossible. Actually, I won't keep it at impossible. I'll just keep it at hard only. Okay? Somewhere between it, okay? Somewhere between this. Okay. So that's the rating from my side. So I think I'm good. Okay. Okay. So I'll just end the live stream over here. Any doubt? Quickly tell me if there is any doubt. Otherwise, I'll just end the live stream. Okay. Okay.